Hey Ari, turn to page 549 in your book. It's lesson 10.2. Multiply a fraction by a whole number using models. So it's kind of like what we did yesterday. So the first question, how much tomato juice is needed for a group of 4 people if each person gets 1/3 cup of juice? So 4 people, if each, meaning every single one, gets 1/3 of juice, how much tomato juice would be needed? First of all, gross, because it's tomato juice. But if you have 4 people and each get 1/3 cup of juice, how can we find that out? Yesterday we showed we could use addition, repeated addition. So 1/3, 1/3, 1/3, and 1/3, which means 4/3 cups of juice. You know that 4/3 cups of juice means 1 1/3 cup. So if 4 people each got 1/3 cup of juice, that is 4/3 cup, or 1 1/3. How else can we write that? Well, we can say 4 times 1/3 equals, and remember when you do 4 times 1/3, you're doing 4 times 1/3. So you're getting 4/3. Same thing, repeated addition or multiplication. It's much faster to multiply because when your numbers get bigger, you just have to do that. You can't just be adding. It'll take you forever. So that's the first question. If each person has 1/3 of cup and there's 4 people, how much cups? We determine 4/3 cups. But the next question is how much tomato juice is needed if they each get 2/3? So now we're saying they're getting more than 1/3. They're getting 2/3 cups. So 2/3 plus 2/3 plus 2/3 plus 2/3. Okay, let's add the thirds. 2/3, 4/3, 6/3, 8/3. So if they each get more juice, 2/3 cup each, they get 8/3, which you know is 2 2/3 cups. So how can we write that as a multiplication equation? Just like we did last time. Still 4 people, but now they get 2/3 cup each. So that's 4 times 2/3, which is 8/3. And how can we draw this as a model? Okay, we can do it many ways. We can use a number line, cut it up into thirds. So we can say for the first scenario, 1/3, 1/3, 1/3, 1/3, which equals, is that how many thirds we had? Yeah, which equals 4/3. We could draw it in a picture. 1/3, 1/3, 1/3, 1/3, which equals 4/3. And of course, there's several other ways you could do it. You could do circles, but your book wants you to do the little bar graph or a number line. So this represents 4/3, as you know, which here's my whole, right? This is one whole. How do I know that? Because it's 1/3, 2/3, 3/3. So I can see that this is more than one whole, right? So 3/3 is a whole with your 1 extra. That's how you get 3 1/3. So somebody should be able to look at this diagram and see that you have 4/3 here. Or look at this diagram and see that you have 4/3 here. Right? Either way, we should be able to tell how many you have from multiplying the whole number times the fraction. Okay, so we did it with 1/3 like yesterday. But now we did it with 2/3, which is not a unit fraction. Works the same way. We can do 3/3, we can do 4/3, 5/3. We can do any fraction by a whole number. It works the same way. So that's what the lesson is about today. So let's get into the examples. I'm going to try to do this all in one video, so I only have to upload it once. So bear with me while I switch pages. All right. Okay, so let me get another blank piece of paper out. 1 second. Oh, I don't have enough hands. Okay, sorry. All right, so the next page is 550. Let's get it up there. All right. There we go. Page 550. Look at your example. Dory lives 1/4 mile from school. If she walks to and from school each day, how far does she walk during a school week? First of all, we know school week, thankfully, is only on Monday through Friday. So that's 5 days. And then you can see in the diagram to school and from school. So to school is 1/4 a mile, but then she has to go from school, which is another 1/4 mile. So how many fourths of a mile is that a day? 1/4 and 1/4 is 2/4 a mile, because you got to get there and she got to get back. So how lucky are you? You just have to walk out to the garage. All right, so you can use addition or multiplication. Here's how they show this. She walks to and from school on Monday, to and from school on Tuesday, to and from school on Wednesday, to and from school on Thursday, and to and from school on Friday. So they're using repeated addition. 1/4 plus 1/4 plus 1/4, etc., all the way to 10/4. Written as an improper fraction or a mixed number. So how far does she walk each week? 2 2/4 miles. That's repeated addition. Another way is, of course, a number line to show the distance she walks. So you start from 0/4 because you don't walk at all. And then you have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, 12/4. Why do we do that? Because she walks to and from school 5 days a week. That should be 10 unit fractions of 1/4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is how they showed it there. Instead of all of the fourths added together, which takes too long, they're showing you that this is 10 times 1/4, which you know is 10 times 1/4, which is 10/4. Also written as 2 2/4, which is the same as 2 1/2, right? 2 2/4 means 2 1/2. You need to recognize that too. All right, that's pretty simple there. All right, so let's go to the next problem on page 551. Oh, hey, now they want to overcomplicate it a little because it's Common Core math, and that's what they do. And yes, there is a deer in the background that you see that you're all too familiar with because you just shot your first one. By the way, congrats again. Okay, so we're on page 552. Another example. All right, calculate 4 times, I can't read that because it's blurry. Okay, calculate 4 times 3/5 to determine how far Jess bikes to and from work in 4 days. All right, here's the diagram. To and from work. So you know that's to work, from work. All right, in 4 days, by the way. So 1, 2, 3, 4. There's her 4 days. She goes 3/5 of a mile, 3/5 of a mile, 3/5 of a mile, and 3/5 of a mile each day. So how will we write that? We could do this. I hate doing this, it takes so long. 3/5 plus 3/5 plus 3/5 plus 3/5, right? 3/5 for 4 days, which is 12/5, which is also 2 2/5. Or we could quicken it up and write 4 times 3/5, right? 4 times 3/5 should still give us 12/5 because for 4 days she went 3/5 mile a day. So let's write that down. For 4 days she went 3/5 miles a day. Now how do we do that? Yesterday we did 4 times 3/5, which gave us 12/5. Voila, it still works even when the fraction doesn't have a numerator of 1. So how far did she walk in the 4 days of work? 2 with 2 extra, so 2 2/5 miles. Okay, we could see that with this bar diagram. We could see the 3/5, and we can also see they broke the 3/5 up into 1/5. 1/5, 1/5, 1/5, which is a 3/5. 1/5, 1/5, 1/5, which is a 3/5. Do you see that? The partitioned 1/5 into 3/5. That's why they're showing you 12 times 1/5 here. Okay, we're just going to look at the bigger picture now that you understand. We can see that 3/5 times 4 is 12/5. We're going to use multiplication like this. Okay, because it's faster, and we're all about faster and understanding, of course, too. All right, so look at the guided practice. Here is the part that I don't love, just because I don't like the way that they're showing you. So I'm just going to run through it real quick, but in real life, I'm not going to make you do it this way. So it says, draw a picture to explain why 3 times 2/5 is the same as 6 times 1/5. All right, well, you can look at this and see. Here's 3 times 2/5, right? Here's a 2/5. Woo, it's hard for me to video and do this at the same time. Let me move this over. All right, so 3 times 2/5. Here's a 2/5, that's 1. Here's a 2/5, that's 2. Here's a 2/5, that's 3. So how much is 3 times 2/5, by the way? Let's count. 2/5, 4/5, 6/5. So 3 times 2/5 equals 6/5, right? You know how to do that. You know how to set it up. 3 times 2/5. 3 times 2/5 is 6/5. Do you see that in the picture? 2, 4, 6. But it's also 2/5 is broken up into sets of 1/5. So you have 1/5 times 1, 2, 3, 4, 5, 6. So basically you're splitting the 2/5 in half. So now you have 6 times 1/5. How does that mean the same thing? Well, let's see. 6 times 1/5 equals 6 times 1/5 equals 6/5. So regardless if we do it this way, 3 times 2/5, or 6 times 1/5, we get the same thing. They just want you to, they just want you to identify that in the picture. Okay, I'm not worried about how they're writing it like that, because that confuses you. As long as you can see that 2/5 times 3 is here and 1/5 times 6 is here, I'm fine with that. Okay, so let's go to write and solve a multiplication equation. Do you know how? I already have the answers up, and that's okay, but look at the pictures. 2 out of 6 are shaded here, and 2 out of 6 are shaded here. So what whole number are we multiplying by? 2. So 2 times 2, 6 is 4, 6, right? Of course, because 2 times 2 is 4, 6. And you can also see that. Then they show it to you on a number line, or they show you another problem on a number line, should I say. You have all of these thirds, 1, 2, 3, 4. 4 sets of 2/3. So here's 2/3, here's 2/3, here's 2/3, and here's 2/3. So what is 4 times 2/3? 8/3. How do we know that? 4 times 2 is 8. 8/3, which is also 2 and 2/3. Okay, so all you have to do is look at the pictures and understand what multiplication equations are being shown. Also, you have to know how to multiply a fraction by a whole number. So another example, 6 times 3/5. How would we do that? 6 times 3/5, which would be 18/5. Okay, now you do this one. 5 times 2, 6. What goes here? What goes here? And what is your answer? Okay, try that one. 5 times 2, 6. Pause the video, I'm sure, for 2 seconds because you're so smart. So 5 times 2, 6 equals 10, 6, which equals 1 and 4, 6, which could also be written as 1 and 2/3. But we'll talk more about that later. All right, so now you have to go through your examples, your independent practice. Let's do the first one together. 1/8, 1/8, 1/8, 1/8, 1/8. That's 5 times 1/8, which would be 5/8, right? Right. Okay, cool. You're gonna do number 5, number 6, number 7, And then she can work with you on 8. Actually, y'all pick which ones you want to do back here that you think really the lesson bases, it's based off the lesson, excuse me. I would try number 11 and number 8 for sure, and number 12, and of course the assessment practice.